Hi friends, today let's learn to write a program in Java to sort an integer array in the ascending order of its values by using bubble sort technique. So what is sorting? Let's take an example. We have an integer array named as m with 5 storage locations. When you look at this array, you can understand that the values in this array are entered without any order. Sometimes we may have to rearrange the elements of an array either in the ascending order of its values or descending order of the values. The process of rearranging the elements of an array either in the ascending order or descending order is known as sorting. When you look at the first array, the elements are not arranged in any order. So this array is an unsorted array. Look at the second array. You can understand that the elements of this array are arranged in the ascending order of its values. -8, -3, 5, 9 and 14. The second array is a sorted array. Now let's learn the bubble sort technique. Let's try to understand what bubble sort technique is. How we can use bubble sort technique to rearrange the elements of an integer array in the ascending order. Let's take an example. We have an integer array named as m with 5 storage locations. Elements are entered into this array without any order. The first value of the array is 14, second value is 9, third value -3, then comes 5, the last value of the array is -8. Now we have to rearrange the elements of this array in the ascending order by using bubble sort technique. Let's try to understand the logic of bubble sort technique. In bubble sort, two consecutive elements of the array will be accessed and compared to check whether the first element is greater than the second element. If the first element is greater than the second element, these values will be interchanged. Now let us see. The first two elements of the array are m of 0 and m of 1. We are going to check if element at m of 0 is greater than the element at m of 1. Here 14 is greater than 9. 14 is greater than 9. So when you arrange the elements in the ascending order, 14 should come after 9. So we have to interchange these two values. 9 should be shifted to first storage location and 14 should be shifted to the second storage location. We have to interchange the values of the index number 0 and 1. How do we interchange the values of two storage locations of the array? M of 1 should be assigned to M of 0 and M of 0 should be assigned to M of 1. Directly if we give the assignment statement, say M of 0 is equal to M of 1, what will happen? Value at M of 0 will be assigned to M of 1. So, first value will be replaced with the second value. So, you lost the first value. So, before you assign the second value to the first storage location, you have to keep the first value safely in another storage location in the memory. So, before we go for this assignment statement, let us use a temporary storage location to store the first value of the array. Temp is equal to m of 0. First value of the array is placed in the temporary storage location. Now, you can assign the value of the second storage location to the first storage location. M of 0 is equal to M of 1. So, to the first storage location, we have assigned the value 9. Now, in both storage locations, we have the value 9. To the second storage location, assign the value of temp. M of 1 is equal to temp. So, from the temp, assign the value to the second storage location of the array. Now, you have accessed the element at index number 0 and 1 and you checked whether the element at index number 0 is greater than the element at index number 1. As we found that 14 is greater than 9, we have interchanged the values. The resultant array after the comparison and swapping operation will be 9, 14, -3, 5 and -8. The original array is 14, 9, -3, 5 and -8. Your array is not sorted. Now you have to take the next two consecutive elements. Let us compare the element at index number 1 and 2. If m of 1 is greater than the value of m of 2, interchange it. Now look at the values. M of 1 is 14. 14 is greater than the value at m of 2 is minus 3. 14 is greater than minus 3. So we have to interchange these two values. 14 should come down and 2 should be assigned to the second storage location of the array. That is the index number 1. So we have to place 14 to temporary storage location. Temp is equal to m of 1. And to m of 1 assign the value of m of 2. M of 1 is equal to m of 2. And to m of 2 assign the value from the temp. M of 2 is equal to temp. So what will happen? After the second comparison and swapping operation, the resultant array will be 9, minus 3, 14, 5 and minus 8. Next, we have to take the values at index number 2 and 3 and compare. Value at index number 2 is greater than the value at index number 3. M of 2 greater than M of 3. Yes, M of 2 is greater than M of 3. So we have to interchange the values as we are going to arrange the array in the ascending order of their values. So 14 should be placed at index number 3 and 5 should be shifted to index number 2. So swapping should be done with the help of a temporary variable. So let us assign m of 2 to temp. Temp equal to m of 2. From m of 2, value is assigned to temp. So 14 is assigned to temp. Now to the storage location, let us shift the value 5. So m of 2 is equal to m of 3. M of 2 is equal to m of 3. And to the index number 3, assign the value of temp. M of 3 is equal to temp. So after the comparison and swapping operation, the resultant array is 9, minus 3, 5, 14 and minus 8. Still the array is not sorted. Let's go for the next comparison. Let's take the values at index number 3 and 4 and compare. Values at index number 3 and 4 are 14 and minus 8. M of 3 greater than M of 4. Two consecutive elements are accessed and compared. As M of 3 is greater than M of 4, 14 is greater than minus 8. As it is greater than minus 8, you have to interchange the values of index number 3 and 4. 4 should be shifted to the last cell and minus 8 should be shifted to index number 3. So after the swapping operation, how the resultant array will be? The resultant array will be 9, minus 3, 5, minus 8 and 14. So the comparison, last comparison what we have done was M of 3 greater than M of 4. So temp equal to M of 3, M of 3 is equal to M of 4 and M of 4 is equal to 10. So you have got the elements of the array arranged in this order. You can see that the highest element of the array is placed at the bottom. After one round of comparisons, how many comparisons we have done? 4 comparisons we have done. Consecutive elements are accessed and compared. Whenever we found that the first element is greater than the second element, swapping operation was done. That means values are interchanged. So after 4 comparisons, we have got the highest element of the array placed in its correct position. So now 14 is in its correct position. Still the array is not sorted. Other values are not rearranged in the ascending order. 9, minus 3. Minus 3 is smaller than 9. 5 is smaller than 9. Minus 8 is the smallest value. So now we have to rearrange the remaining 4 elements of the array in the ascending order. Let us consider this as stage 1. Stage 1 of comparison. At stage 1, we have done 4 comparisons. There are 5 elements in the array. Number of elements is 5 and we have done 4 comparisons. Now let's move on. At the beginning of the second stage, you can see the status of the array. Stage 2. In stage 2, again we start comparisons from the beginning of the array. First 2 elements of the array will be accessed and compared. So m of 0 is greater than m of 1. 9 is greater than minus 3. So interchange the values. After interchanging, the resultant array will be minus 3, 9, 5, minus 8 and 14. We need not touch 14. 14 is in its right place. Now let's go for the next comparison. Element at index number 1 and 2 should be accessed and compared. M of 1 greater than M of 2. Yes, M of 1 is greater than M of 2. So we have to interchange these two values. So after the comparison and interchanging operation, the resultant array will be minus 3, 5, 9, minus 8 and 14. 14 need not be touched. Now let's go for the next comparison. Element at index number 2 and 3 should be accessed and compared. M of 2 greater than M of 3. M of 2 is 9, M of 3 is minus 8. So we have to interchange these two values because smaller value should come first. So 8 will be shifted to index number 2 and 9 will be shifted to index number 3 with the help of a temporary variable. So after the swapping operation, the resultant array will be minus 3, 5, minus 8, 9 and 14. Now when you look at, so we have accessed all the remaining 4 elements in the second stage of the comparison, compared to consecutive values. Whenever we found that the first value is greater than the second value, we interchanged it. So at the second stage, how many comparisons we have done? The number of comparisons done is 3 and 2 elements are placed at its correct position. 9 and 14 are placed at the bottom of the array in the last 2 cells of the array. Now still the array is not sorted. Minus 8 is smaller than 5 and minus 3. So minus 8 should be brought to the first cell. We have to continue the operation. Now when you look at this, there are 5 elements in the array. During the first stage of comparisons, we have done 4 comparisons. So the biggest element is placed at the last cell of the array at the end of first stage. When you move to the second stage, as the biggest element is placed at the last cell of the array, we had to carry out 3 comparisons. Number of comparisons are getting reduced as you move from one stage to the next stage. 4 comparisons here, 3 comparisons here, but still the array is not sorted. The remaining 3 elements we have to access, compare and interchange. So let's move on to stage 3. At the beginning of stage 3, we have the elements arranged like this. 9 and 14 are in their correct places. 9 and 14 are moved to last 2 cells of the array. Now the rest of the values we have to rearrange. So the comparison will start from beginning onwards, from the first cell onwards. M of 0 and M of 1 will be accessed and compared. M of 0 greater than M of 1. Minus 3 greater than 5. No. Minus 3 is not greater than 5. So we need not interchange. So the resultant array after this comparison is minus 3, 5, minus 8, 9, 14. 9 and 14 we need not touch. Now let's access the element at index number 1 and 2. M of 1 greater than M of 2. M of 1 is 5, M of 2 is minus 8. M of 1 is greater than M of 2. So we need to interchange the values. Minus 8 should be shifted to index number 1 and 5 should be shifted to index number 2. With the help of a temporary variable, interchange the values of these two storage locations. The resultant array after the comparison is -3, -8, 5, 9 and 14. So we have compared all the three consecutive values one after the other, and we have rearranged the elements of the array like this: -3, -8, 5, 9 and 14. Now you can see that the biggest three values are placed in the last three cells. Still the array is not rearranged. -8 is smaller than -3. So we have to go for one more level of comparison. At stage 4, let us see what happens at stage 4. At the beginning of stage 4, we have the array like this: -3, -8, 5, 9 and 14. 5, 9 and 14 are in their correct places. So now let's compare the first two elements of the array and interchange the values. -3 greater than -8. Yes, m of 0 is greater than m of 1. So we have to interchange. -8 is the smaller value. -8 should be shifted to index number 0 and -3 should be shifted to index number 1. With the help of a temporary variable, we have to rearrange the elements of the array. So after the swapping operation, the resultant array will be -8, -3, 5, 9 and 14. Now when you look at the array, you can see that the array is completely sorted. All the elements of the array are arranged in the ascending order of their values. -8 is the smallest element of the array. The biggest element of the array is 14. It is placed at the last cell. So how many comparisons we have done? How many stages of comparisons we have done to sort this array? So as you have seen, we have passed through 4 stages of comparisons. At the first stage, stage 1, we have done 4 comparisons, and at stage 2, 3 comparisons. At stage 3, 2 comparisons, and at stage 1, in the last stage, 1 comparisons we have done. So as the stages are advanced, as we move from one stage to the next stage, the number of comparisons are getting reduced. So to bubble sort an array which has 5 values, how many stages are involved? 4 stages of comparisons are involved. How many comparisons are done? We have carried out total 10 comparisons. 4 plus 3 plus 2 plus 1. So to carry out all these comparisons and to swap the values whenever it is required, we have to use a nested loop. The outer loop can be used to change the stages, and the inner loop can be used to carry out the comparisons at each stage. So let us set a nested loop to carry out this operation. As there are 5 elements in the array, n is equal to 5. How many stages of comparisons we have done? We had 4 stages. So let us set the outer loop to change the stages. So for an outer loop index variable, I is equal to 0, I less than, I starts from 0, I less than 4 plus I. So the variable I takes the values 0, 1, 2 and 3. 4 stages. When the value of I is equal to 0, 4 comparisons we have to do. When the value of I is equal to 1, 3 comparisons we have to do. When the value of I is equal to 2, 2 comparisons. When the value of I is equal to 3, 1 comparison we have to do. So the inner loop should be set in such a way that number of comparisons should get reduced as we move from one stage to the next stage. So for j is equal to 0, j less than 4 minus the value of I plus j. If m of j greater than m of j plus 1, take two consecutive elements, jth element, 0th element and first element. If the first element at index number 0 is greater than the element at index number 1, interchange them. Temp is equal to m of j. M of j is equal to m of j plus 1. M of j plus 1 is equal to temp. Inner loop is closed, outer loop is closed. Let us see how it works. When I is equal to 0, j takes all the values from 0 to 3. So when j is equal to 0, I is 0. So 4 minus 0. 4 minus 0 is 4. So j takes all the values from 0 to 3. 0, 1, 2, 3. So when j is equal to 0, element at 0 and 1 will be compared. When j is equal to 1, element at 1 and 2 will be compared. When j is equal to 2, element at 2 and 3 will be compared. When j is equal to 4, element at 3 and 4 will be compared, as we have used j and j plus 1. So 4 comparisons will be done. And when the I loop goes for the next iteration with the value 1, second value, here the condition will be changed. 4 minus I, 4 minus 1. 4 minus 1 is 3. So j will go till the value of 2 only. 4 minus 1, the limit is 3. So j less than 3. J less than 3 means j takes the values from 0, 1 and 2. So first and second element is compared. Second and third element is compared. Third and fourth element will be compared as we have used it. When j is equal to 2, m of 2 greater than m of 2 plus 1, m of 3. So 3 comparisons will be done at the second stage. Outer loop goes for the next iteration with the value 2. So here 4 minus 2, value of I is 2. 4 minus 2 is 2. Value of j will be less than 2. So j takes the value 0 and 1. At this stage, element at 0 and 1 will be compared and 1 and 2 also will be compared. 2 comparisons will be done at third stage. Now, when the I loop goes for the next value, 3, last value, 4 minus 3 is 1. So the limit is 1. J takes the values from 0 to j less than 1. J loop will iterate only once here, because the upper limit is 1. So when the value of j is equal to 0, m of 0 greater than m of 0 plus 1. That is m of 1. So one comparison is done in the last stage. So total 10 comparison is done. Inner loop executed 10 times to sort an integer array with 5 elements by using bubble sort technique. So let us generalize this. As we had 5 elements in the array, the limit is set as 5 minus 1. I loop. I is equal to 0, I less than 4. I less than 4 means 5 minus 1. Suppose we have to sort an integer array with n elements. So how the limit has to be set? N elements in the array. Size of the array is n. Size is equal to n. We do not know what will be the value of n entered by the user. So when it was 5, the limit was set as 5 minus 1. I less than 4. So let us replace this 4 with I less than n minus 1 plus I. Here how the condition should be changed? J less than n minus 1 minus I. N minus 1 minus I plus j. The upper limit should be set like this to bubble sort an array with n storage locations or n values. Now let's write a program to bubble sort an integer array with 10 integer values in the ascending order. As we have to use the scanner class in our program, import java.util.star. Public class bubble sort. A meaningful name is given to the class. Body of the class is opened. All the executable statements in Java are written inside methods. So we have opened a method here, public static void sort. You can give any name to the method. We have to use a nested loop to carry out the sorting operation. Two integer type variables I and j are declared. To swap the values, we need the help of a third variable. So a temporary storage location is declared. An integer array with 10 storage locations are created. Scanner class object is declared to enter the values into the array. A prompt is given to the user to enter 10 integer numbers. System.out.println enter 10 integers. To accept and store the values into the array, we have set a loop. For I is equal to 0, I less than 10. As the size of the array is 10, the first index of the array is 0 and the last index of the array will be 1 less than the size of the array. That means the last index of the array is 9. So the loop is set in such a way to iterate through all the index numbers of the array. For I is equal to 0, I less than 10. So I takes the value till 9 plus I. M of I is equal to scanner class objects. Next in the method is used to input the value from the keyboard. When the loop completes its iteration, 10 values will be stored into the array named as M. Now let's bubble sort to the array by using a nested loop. As there are 10 elements in the array, the outer loop is set in such a way to iterate 9 times. So the loop index variable I started with 0, I less than 9, 10 minus 1, n minus 1. General format is to bubble sort an array with n elements. You can set the outer loop index variable's limit as n minus 1. So here the number of values in the array are 10. So 10 minus 1. I is equal to 0. I less than 10 minus 1. I less than 9 plus I. Inner loop should be set in such a way that j is equal to 0. J less than n minus 1 minus I. 10 minus 1 is 9. 9 minus I plus j. If the first element of the array is greater than the second element, assign the first element to temporary storage location and assign the second element to the first storage location. To the second storage location, assign the value of temp. So, if m of j greater than m of j plus 1, temp equal to m of j is equal to m of j plus 1, m of j plus 1 is equal to temp. When this nested loop completes all its iterations, you will get the array sorted in the ascending order. Now, the last step is to print the sorted array. Let us display heading system.out.println sorted array. A single loop is used for printing the sorted array. As the array index starts from 0, last index of the array is 9, I is equal to 0, I less than 10 plus I. System.out.println m of I. So this loop will print all the elements of the sorted array in the ascending order. Method is closed, class is closed. Thank you for watching. For more videos, like, share and subscribe.